Okay, let's work through this memo here. Let's create the memo. Here, red pen. All right, so first question. Given the number 36, write down all its factors. Okay, so all the factors of 36, 1, 2, 3, 4, 6, 9, 4 times 9, 3 times 12, 2 times 18, and 1 times 36. So those are all the factors of 36. And now the first four multiples of 36, that would be 36, and then 72. Next multiple would be 108, and the fourth one 144. Okay. We'll state whether each of the following numbers are prime, composite, or neither. So 13 is a prime number. 51 can be written as 3 times 17, so that's a composite number because it has different factors than 1 in itself. Remember, a prime number is any number that can only be divided by 1 in itself, but 1 does not count, since 1 and itself is the same thing here. So 1 is neither. So it's not composite and it's not prime. 91 91 can be written as 13 times 7, so that's going to be composite. 0 is neither of them, and 61 is a prime number. All right. Next up, question 3. Write 5 times 5 times 5 times 5 in index notation. So that would be 5 times by itself 4 times, which gives us 5 to the power of 4. Now for question B, write 7 to the power of 3 in expanded notation. So now we just have to expand. 7 times itself 3 times. So 7 times 7 times 7. Okay, prime factorize the following. So now we can use the ladder method for that. So 24 can be divided by 2, which gives us 12. We can divide that by 2 again. 6 divided by 2 again gives us 3. Now we can't divide by 2 anymore. Then we try the next prime number, which is 3. And 3 divided by 3 is 1. Okay, so this we can write as, how many 2's do we have? 1, 2, 3 of them. So this is 2 to the power 3 times 3 to the power 1. 40, let's do the same thing. So we can divide it by 2, which gives us 20. Divided by 2 again, which gives us 10. Divided by 2 again, which gives us 5. And 5 is a prime number, it can only be divided by itself. So then we have 3 2's, so 2 to the power 3 times 5. Yeah, and then for 63, we cannot divide this by 2. Can we divide it by 3? Yes. So 63 divided by 3 is 21. We can divide that by 3 again, which gives us 7. And then we can divide that by 7 to give us 1. So this has 3 squared times 7 as its prime factors. Okay. Now use your answers to number 4 above to find the highest common factor and the lowest common multiple of 24, 40, and 63. So for the highest common factor, what we have to do is we look for which number is common to all three. So let's look at the 2's. Do all three of them have a 2? This one has 2's, this one has 2's, this one does not. So we cannot use a 2. 3's, this one has a 3, this one does not have a 3. So that's not common. So that means there's nothing common. So if there are no common factors, then the highest common factor is just 1. For the lowest common multiple, now we don't look for things that are common, but we look for any number that there is and we use the highest value of that. So, for instance, the 2's. So we see there is a 2 somewhere, then we use the 2 with the biggest exponent. So this is 2 to the power 3, also 2 to the power 3, no other 2's. So the 2 with the highest exponent is 2 to the power 3. Then we look at the next number, 3. Okay, 3 to the power 1, 3 to the power 2, that's the biggest, so we use that, 3 to the power 2. Next we have a 5, 5 to the power 1 is the biggest, and then finally we have the 7. So 7 to the power 1 is the biggest 7. And then we just calculate this. So 2 to the power 3 is 8. 8 times, well, let's write it all out. So 8, 3 squared is 9, times 5 times 7. So now we can do 8 times 9 is 72, times 5 times 7. Let's continue here. So then 72 times 5 is 360, times that by 7. So then we get 300 times 7 is 2,100. 60 times 7 is 420. So 2,100 plus 420 is 2,520. So that is our lowest common multiple. Okay, question 6. Evaluate the following. So this is just a list of numbers. You guys have had lots and lots of squares, cubes, square roots, and cube roots to memorize. I think all the way up to 20. So these ones you should just know from memory. But if you don't, so let me just write the answer. So the square root of 81 is 9. The cube root of 512 is 8. 13 squared is 169. And 4 cubed is 64. So that'll be good enough to get your marks. But let's see, how would we get this if we didn't know it? So we can figure out the answers. So the square root of 81. So 81 we can write as 3 to the power 4, right, by prime factorizing it. And then we can say, so there's an imaginary 2 if there's nothing written for a square root, right? So now we can say it's 3 to the power inside exponent divided by the outside exponent. So 4 divided by 2, and that gives us 3 to the power. 4 divided by 2 is 2. And 3 squared is 9. Okay, so that's how we can get to 9 if we don't know it from memory. Let's do the same with the next one. So the cube root of, then 512, we can write this 2 to the power 9. And we can write that again as 2 to the power inside exponent divided by outside exponent. So 9 divided by 3. That gives us 2 to the power 3, which gives us 8. Okay, 13 squared. Well, that just means 13 times 13, right? So you can just do the multiplication. 3 times 3 is 9. 1 times 3 is 3. Next line we start with a 0 for the tens. Then 3 times 1 is 3. And 1 times 1 is 1. And we add that up. 9 plus 0, 3 plus 3, and 1. And 169 is our answer. 4 cubed, that just means 4 times 4 times 4, right? Okay, so what I'm going to do is I'm just going to first do 4 times 4, and then that answer I'm going to multiply by 4 again. Okay, so 4 times 4 is 16. And then we're just going to say 16 times 4. So 6 times 4 is 24. 1 times 4 is 4, plus 2 is 6. And that gives us the 64. Okay, calculate the following. So first up we have 7 minus positive 3. So plus and a minus makes a minus. So we have 7 minus 3. And 7 minus 3 is 4. Okay, next, negative 3 minus 7. So we're a negative 3 on the number line. And then we have to move 7 to the left because we're subtracting 7, right? So we're getting 7 this way. So that'll give us all the way to negative 10. So negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So that's negative 10. 5 minus negative 2. So a minus and a minus make a plus. That gives us then 5 plus 2, which is 7. Here we've got negative 3 minus minus, or minus and negative. 2 negatives make a positive. So that gives us negative 3 plus 8. And that's the same as just saying positive 8 minus 3. So again, we can look at the number line. If we're started negative 3 and we go 8 to the right, when we go to the right is negative 2, negative 1, 0, 1, 2, 3, 4, 5. So negative 3 plus 8 is 5. Okay, number E. 38 divided by negative 2. So we've got a positive and a negative. That gives us a negative. And then 38 divided by 2 is 19. Okay, that's as easy as that. Now I've got multiplication. Again, a negative times a negative is a positive. And then 4 times 5 is 20. There we go. Okay, next up, question G, a bit of a longer question. So here we just have to apply our BODMAS rules, order of operations, what do we do first, second, third, etc. So we're going to start with the bracket. So here we have a big bracket. Inside the bracket, we've got another bracket, so we have to start with that. So this bracket says -2 all squared. So that means -2 times -2, which is 4, plus 14 divided by -9. Now again, we have to work inside the bracket. 4 plus 14 is 18, divided by -9. So positive divided by negative is a negative. 18 divided by 9 is 2. There's our answer. Okay, next up, another one of these types of questions. So let's start inside the bracket here. Inside this bracket, we've got another bracket. So 24 divided by -6 is going to be -4. So let's rewrite everything else. Minus bracket -2 cubed divided by, and we said 24 divided by -6. Positive divided by negative is negative. 24 divided by 6 is 4. And then plus 3 squared. Close bracket, close another bracket, all squared. Okay, what do we have to do next? So now, well, there's a couple of things we can do, but let's do the exponents first, because that counts. If we're looking at BODMAS, this O, it includes the word order. So it usually stands for of, but it's also order, which means exponents. So exponents are included here before division and multiplication. Okay, so we've got 20 minus, and then -2 cubed, so that's -8, divided by -4, plus, and then 3 squared is 9. Close brackets and squared. So next, we now have the division, goes before addition. So -8 divided by -4 is 2. Negative divided by negative is positive, and 8 divided by 4 is 2. Plus 9, close brackets and square. So now we have 20 minus, and then 2 plus 9 is 11 squared. And then we just get 20 minus 11 is 9 squared. And that gives us 9 squared is 81. Okay, so see, it's not that difficult. It looks complicated, it looks intimidating, but you just do step by step, follow your BODMAS rules. Question I. Okay, again here at the top, we can do 3 to the power 3, which is 27. Then at the bottom, we can do 5 squared, which is 25, minus, now 4 times 6 is 24, plus 1. That's going to give us 27 over then 25 minus, and 24 plus 1 is 25. So that gives us 27 over 25 minus 25 is 0. And if you have anything divided by 0, if you try that in your calculator, you'll see you'll get a math error. Unless you have a really good, well, no, it's still going to give you a math error. But if it's a really good one, it might tell you which type of error it is, instead of just saying it's a math error. So anything divided by 0, for you guys, all you have to know is that is undefined. Undefined. So anything divided by 0 is undefined. Okay, question 8. Evaluate the following. So again, some of these ones you should just know from your list of numbers that you had to learn in the beginning of the year and a bit last year already. So the cube root of -8, that's going to be -2. So if you have a negative number underneath a root, and it's an odd root, like the third root or the fifth root or the seventh root, etc., then the answer is also going to be negative. Okay, over here, we've got an even root, the square root of -16. So this is non-real. That's another math error on the calculator. So in reality, this answer is actually 4i. So you can, I believe if you type this into Google, you'll probably get something like 4i. Google should be smart enough to know that. But normal school calculators, we just work with real numbers. So it's just going to be non-real. This is not a real number. It has an actual answer, but it's not a real number. It's a complex number. Okay, so any negative number underneath an even root. So set the square root, the fourth root, etc. Any even root of a negative number is non-real. So non-real and undefined are the two types of numbers that are not real numbers that you have to know. Okay, question 8, the cube root of 0. So what do you think you have to multiply by itself 3 times to get 0? That's right, 0. Because 0 times 0 is 0, times that by 0 again, we get 0. So any root of 0 will remain 0. Because it doesn't matter how many times you times 0 by itself, the answer is always 0. Next up, question D. Here we've got the square root of 36 plus 64. Now, if we have plus or minus, addition and subtraction underneath a square root, we can't split the root up into two different parts. So what you cannot do is you cannot say this is the square root of 36 plus the square root of 64. That'll be wrong. Okay, you cannot do that with plus and minus. With multiply, like in the next one, we can do that. And the same with divide and f. But with plus and minus, we cannot do that. So what we need to do instead is we need to do the addition first. So 36 plus 64 is 100, and then we just take the square root of 100, which is 10. Okay, question E. This one we can split up, so we can say this is the square root of 36 times the square root of 64. And the square root of 36 is 6, square root of 64 is 4, and then 6 times 4 is 24. That's probably the easiest way to do it. You could have also done work out what is 36 times 64, and that would be, what is that, 576, I think, and then take the square root of that. But that's more complicated, right? Bigger numbers. And this, I believe, is a non-calculator test, so it's better to split them up if you can. Okay, question F. Now, this is the cube root of something being divided. And again, we see it's a negative and an odd root. So the answer will be negative. Now, what we can do is we can split this up. We can say this is the same as the cube root of negative 64 divided by the cube root of 27. And then we just get the cube root of 64, we know is 4. And because it's a negative with an odd root, it's going to be negative 4. And then the cube root of 27 is 3. That's your answer. Okay. Question 9. Simplify these fractions. Okay, so here we can divide both the top and the bottom by 6. And then we get 3 over 2. And sometimes they can probably leave your answer as a mixed number. Then as a mixed number, this would be 1 and a half. 1 and 1 over 2. But we'll get to mixed numbers a little bit later. You'll think of the following question. This one, we can divide both by 3. So 33 divided by 3 is 11. 45 divided by 3 is 15. And that is simplified. But always, once you have your answer, just check if there's not anything else you can simplify by. Because maybe you don't see the biggest factor first. Like in this case, we could have said, let's divide both by 2. Then we get 9 over 6. But that's not the final answer, because both of these can still be divided by 3 to get 3 over 2. So always check if your answer is fully simplified. If not, continue simplifying. Okay, question 10. Change the following to improper fractions. Okay, so to change a mixed number into an improper fraction, we'll take the whole part, 3, times the denominator. So 3 times 7 is 21, and then we add the numerator. So 3 times 7 is 21, plus 5 is 26, and the denominator is still 7. Same over here. We'll go 6 times 6 is 36, plus 1 is 37, and the denominator is still 6. Now change the following into mixed numbers. So here we now see how many times can 3 go into 17. Well, it can go into 17 5 times, because 3 times 5 is 15, and then there's 2 remaining, so 2 over 3. In this case, 17 can go into 53 3 times, and 17 times 3 is 51, so again there's 2 remaining, and the denominator remains 17. So you see in both of these cases the denominator does not change. That'll be the same. Okay, question 11. Calculate the following. So here we have multiplication of fractions. So different ways we can do this. probably the way I would suggest is see if you can simplify the fractions first. If you can do some simple cross cancellation or just simplifying a fraction, probably that's best to do that first and then do the multiplication. But you could also just straight up multiply 8 times 30 and then 5 times 12. But let's do both ways in this one actually. So we can say 30 and 5 can simplify to 1 and 6. And then 6 and 12 can simplify to 1 and 2. Okay, and then 8 and 2 can again simplify to 1 and 4. So you can stop at any point along here once you think the numbers are small enough, or you can keep going until you can't simplify anymore. Now in this case it's quite nice because now I've got 4 times 1 is 4, and 1 times 1 is 1, so 4 over 1 is just 4. But what we could have also done, let me just, this is a blueprint, let me just get that one. So what we could have also done is just do multiplication straight up. So 8 times 30, top times top, is 240. And then 5 times 12 is 60. And then just simplify that. So 240 divided by 60 is also 4. So that's also fine. So you can first simplify and then do the multiplication. Or you can first do the multiplication and then simplify. Either one is fine. Okay, next one. Now we've got division. So what we want to do with division is, what do you guys call it? I think you call it KFC. Keep, flip, change or something like that. So we've got 8 over 5. Now, instead of division, we're going to change that into multiplication. And then we're going to flip the last fraction around. So 30 over 12 will become 12 over 30. And now we're just doing multiplication again. So again, we can first simplify and then multiply, or first multiply and then simplify. I'm going to simplify again. So I'm going to divide both of these by 6 to give me 5 and 2. And then I'm just going to multiply. So 8 times 2 is 16. 5 times 5 is 25. And that's our answer. And lastly, we've got subtraction here. Subtraction and addition are more difficult, usually, or at least it takes longer in fractions than multiplication and division, because we first need to get a common denominator. So the lowest common multiple of 5 and 12 is 60. So we can put both of these over 60 and make them into equivalent fractions like that. And it's a minus in the middle. So 5 times 12 will give us 60. Then at the top we also have to do 8 times 12. And over here we had 30 over 12. But 12 times 5 was 60. So at the top we also have to multiply by 5. So that'll give us 8 times 12 is 96. And then 30 times 5 is 150. And then we can just do that. So 96 minus 150 is negative 54. And we can see this can still simplify further. So 54 and 60 can both be divided by 6. So that gives us negative 9 over 10. And now negative 9 over 10 is exactly the same as 9 over negative 10. And that's exactly the same as negative 9 over 10. So it doesn't matter if the negative is at the top, at the bottom, or in front. As long as there's only one negative, it's the same thing. Question 12. Complete the table by filling in the missing values. So here we have to change fractions to decimals and percentages and vice versa. So a fraction to a decimal, many ways we can do that. We can just do the division, 2 divided by 5, and find the answer. Or we can say, find an equivalent fraction with a denominator of a multiple of 10. I mean of a power of 10. So over 10, over 100, over 1,000, something like that. So here we can say, 2 over 5 is the same as 4 over 10, right? Same as 4 over 10. And 4 divided by 10 is easy, that's 0.4. So that's why dividing by, what do you call it, a power of 10 is quite easy. So that makes the decimal part easy. And to convert anything to a percentage, we just times it by 100. So 0.4 times 100 is 40%. Now 0.65% is easy, times it by 100, 65%. And then as a fraction, we'll start off by saying that's 65 over 100 as a percent, right? Then we can simplify. Divide both of those by 5, and we get 13 over 20. 3.44 times it by 100. That's going to be 344%. And as a fraction, that's going to be 344 over 100. And then we simplify. Okay, so I'm going to simplify over here. So we've got 344 over 100. We can divide by 2, for instance. Let's say we don't know what the highest common factor is. Let's just try 2 because we see they're both even. So that'll give us 172 over 50. Now we can divide by 2 again. So that's going to give us 86 over 25. And now there are no more common factors. So 86 over 25 is our fraction. Remember to always simplify our fractions. Okay, 80%, take that to a decimal, we divide it by 100. So that's 0.8. Again, 0.8 is just 8 over 10. Then we need to remember to simplify, and that'll give us 4 over 5. Okay, 5 over 8. So 5 over 8, we can convert that to something over 1,000. So 8 times 125 is 1,000. So at the top we also have to multiply by 125. And that then gives us 625. So 625 over 1,000 is 0.625. And then times it by 100 to get to a percentage, 62.5%. Okay, 72%, again divided by 100 to get the decimal, 0.72. And then we're going to start with 72 over 100 for the percentage, and then simplify. So let's do the simplification here again. 72 over 100, you can divide both by, let's do 4. So that's going to be 18 over 25, and nothing more we can simplify there. So 18 over 25. All right, question 13, rounding off. So round 384.698 to the nearest 100. So this is the hundredths value. So the 8 to the right of the hundredths value is bigger than is 5 or bigger. That's going to change that into a 4. So it's going to be 400. Okay, to the nearest 10. So that's the 8. So that's going to be 380 because the 4 is less than 5. Hundredth, so that's the 9's value here. So 8 is going to make the 9 into a 10, but they can't have a 10 there, so that's going to make the next one into a 7. So that's going to be 384.70. And remember, you have to add the 0 because it's the hundredths, the second place here that we're looking at. Question 14. So given this expression, find the number of terms. Okay, so terms are separated by a plus or a minus, and terms are combined with brackets. So we've got 1 term, 2 terms, 3 terms. Right? Notice the pluses separate the terms. If there weren't brackets in here, this would also separate these 2 terms. But since they're in brackets, they're combined into a single term. Okay, so we have 1, 2, 3 terms. The coefficient. So coefficient is what the thing that's being multiplied with this variable. So the coefficient of x squared. So what is being multiplied by x squared? 3 over 2. And remember, if there was a negative, include the negative. But that is going to be 3 over 2. Coefficient of x, what's being multiplied by x? Not just negative 5, it's negative 5 and y. Remember that. So negative 5y. Sorry. Coefficient of y, so again, the whole negative 5x is being multiplied by y. So the coefficient is not just negative 5 or x, it's negative 5x. And remember the sign goes with it. Okay, the constant term, so the constant term, that's the term that does not have any variables with it. So that's just going to be positive 3. That's the only term that does not have any variables. It's constant. And the index of the first term, so here's our first term. And the index, that's the exponent part there. So index of the first term is 4. Okay, simplify these. So we have to see what are like terms here. So like terms are terms that contain exactly the same letters with exactly the same exponents for each letter. So here we have PQ, PQ, and PQ, so they're exactly the same. So we've got 7 of those minus 3 of those will give us 4 of those, plus another 5 of those. So 4 PQs plus 5 PQs is 9 PQs. Okay, next one. We've got TK cubed, T cubed K, and KT cubed. Okay, so which are like terms here? So these two are like terms, because they both have a K and a T to the power 3. So this first one we can just rewrite, nothing changes here. But then these we can add. So we've got negative 8 of these things plus 13 of them. So negative 8 plus 13 is positive 5 of those things. So t cubed k. You can also have written kt cubed. Doesn't matter which one you write first, the t or the k. That's irrelevant. So actually, often, the standard way to do this would be to do it alphabetically. So let me do this. So 13k cubed t for the first one, just write it alphabetically. It doesn't really matter, but that is just the norm. So it might be a good idea to just get used to that. And then negative 8 plus 13 is positive 5, and it's kt cubed. Okay, question 16, and then 17 is the last one. Almost there. So question 16, expand and simplify. So here we multiply in. 3 times x is 3x. 3 times 5 is positive 15. Negative times positive 2x is negative 2x. And then negative times negative 4 is positive 4. Collect like terms. So 3x's minus 2x's is 1x. And then positive 15 plus 4 is positive 19. Okay, next one. So what do we do first? We first have to remove the brackets here. So we've got the x cubed plus 4x, then minus 2x squared, and then minus 4x plus x squared. Okay, collect like terms. So x to the power 3s, there's just that 1, so we keep that. Now the x squared, so negative 2x squared plus x squared. So negative 2 plus 1 is negative 1. And then 4x minus 4x cancel out there, and that's 0. That's nothing. So this is our final answer. Okay, question 17. Simplify these. Okay, so the 16 and the 12 can simplify to 4 over 3. Yeah, now the x to the power 5 and x to the power 3, most of the x's are at the top, so we're going to write the x at the top. And the difference between 5 and 3 is 2. So we can write that, that's the exponent. And the y squared cancel out. So that's our final answer here. Question B. Okay, so let's do this in a couple of steps. So I'm going to write 3. And then we're going to multiply the exponent with the exponents inside. So this 2 has an exponent of 1. So we get 2 to the power 3, x to the power 9, because 3 times 3 is 9, y to the power 21, because 3 times 7 is 21, and then times x and times y. Okay, so now we can times the numbers. So 2 cubed is 8, right? So 8 times 3 is 24. Then we multiply the x's. So x to the power 9 plus, times x to the power 1. Then we add the exponents, right? So 9 plus 1 is 10. And then the y's. 21 plus 1 is 22. That's our answer. Now the square root of 81x to the power 6y to the power 10. So again, we can prime factorize. Yeah, let's do the prime factorization method here. So square root, then 81 is 3 to the power 4. So we still have x to the power 6y to the power 10. And now we can say that's 3 to the power 4 divided by 2, x to the power 6 divided by 2, and y to the power 10 divided by 2. And that's our answer. I'm just going to write the 3 squared as a 9. So 9x to the power 3, y to the power 5. And the last question for this memo, we're going to have the cube root And again, let's do the prime factorization method. So 64 is 2 to the power 6. And then we still have x to the power 15, y to the power 21, over 27 is 3 to the power 3, x to the power 6, z to the power 39. Okay, so what do we see here? There are x's at the top and the bottom. So let's first simplify that bit. So let's keep the cube root. We still have 2 to the power 6. But now the x's, there are more x's at the top, so we'll keep the x's at the top. And the difference between 15 and 6 is 9. Let's just we just simplify the x's like that. Okay, and then y's at the top. At the bottom, we've got our 3 cubed, and we've got our z to the power 39. Because we simplified the x's, right? Now, we can do the division thing. We divide the exponents. So at the top, we've got 2 to the power 6 divided by 3, which is 2. X to the power 9 divided by 3, which is 3. Y to the power 21 divided by 3, which is 7. At the bottom, 3 to the power 3 divided by 3, which is 1. We don't have to write that 1. And z to the power, we just rewrite the z. So z keeps on looking like a 2. Z to the power 39 divided by 3, which is 13. And again, that's good enough for the final answer. I'm just going to change the 2 squared to a 4. So 4x to the power 3, y to the power 7, over 3, z to the power 13. And that's our final answer. Okay, I hope this memo was useful. Good luck for the exams.